Hey YouTube. Nope. Just this is just Logan. I'm actually here to give a quick rundown of a little project I've been working on called for that game company. It's a short little project that was to demonstrate my domain expertise and my skill set, so that there is a little bit more comfort in understanding where I sit. Uh, at a high level, what this video is going to cover is just a rundown of the repository and how to get it, how to set up the repository and the requirements for this actual project. And we're gonna take a moment to explain like actually what the game was supposed to be, and then we're gonna take a stroll down the actual product. And I'm gonna explain how the testing was, and then dive a little bit into the front end that I had mocked up. And at each point of this, we're gonna kind of discuss just some overall thoughts and potentially like interesting stories that came about during the development of this. So you can find my project at my GitHub, github.com Logan Connect. That's just my first last name. It's not particularly special. So if you look in my repositories, you'll see that there is a project called That Game Company Interview Exercise. And at the root page of it, you're going to just see some general information. Basic stuff, you're just going to copy the URL, and then you're going to just do a git clone, paste this in, and then you'll go into the repository that it created. So now you should have everything there. Real quick, I want to just call out that if you go to the documentation directory here, you're going to see some general information on what needs to be done. You'll want Python installed. You'll also want something called libev installed. This is for the load testing. And then you'll also want to get Postman installed if you're looking to actually do any playing around with this for yourself. At the next step, after you've installed these items, you're going to want to install the requirements. Really what you'll want to do is install the requirements in a virtual directory. So I'm going to make a virtual directory for Python at the root of the directory. And so to take a step back, for those of you who aren't familiar with Python or what this project was built using Python, more specifically a framework called Django that is very popular in Python for web servers. And I'll go a bit more into this later as we progress, but the code that you're going to see here is predominantly all Python with some general developer tools like Makefiles and shell scripts, and maybe even a little bit of JavaScript. At this point, we now have a virtual environment created, which just means for the sake of Python that you have a self-contained development environment, meaning that your global project space will not be affected by the libraries and configurations that I do for this project specifically. So the next step is you're going to want to install the requirements for development. And you can do the actual just general requirements, but we do the development because in this example, I'm going to want to demonstrate some of the actual testing requirements that were a part of this. So at this point, it should be done with all the base level requirements, and that I mean everything required to just actually execute the project. While this is going on, we're going to open up Postman real fast, and we're going to import some of the settings. For those of you who aren't familiar, Postman is a tool for doing some simple REST API testing, or really any type of web request testing. It's predominantly used for REST API testing. And in my case, that is what I used it for. If you haven't used it, I would definitely recommend trying it out. It's a fantastic tool for doing that. You're going to want to click the import here to import a collection that I've already made, and it should be available in the repo. You're going to choose file and then go to this v1 collection and then just open that up. And what you're going to get is a set of 19 endpoints that have been configured, and therefore clickhole the game. And so using that as a springboard into the next discussion, we're going to take a moment to explain both the requirements and the game itself. And so how this project started is that I was given a list of requirements right here, which is just very general. It's create and host a multiplayer clicker game where you can log in and have an associated user account. You can click something to generate some type of currency. You can see real-time the stats of other players that are actually playing. You can spend your coins as a gift on another person, and then you should be able to reciprocate as well. And it should support at least some level of concurrency between multiple users. There was a specification not to spend too much time on the interface, so I did take that to heart and didn't really work too much on the interface. Now, from a design standpoint, what this actually came out to be is it's something called Clickhole the game. And basically, Clickhole, the idea of the game is just that everybody is a digger, and they're all trying to dig as far as feasibly possible. As it got fleshed out, I was thinking maybe you would dig through different planets, and then that's a mechanism of progression, is getting to the core of each planet. And then the idea is that other players could only help you, and that the effects from other players would be multiplied or weighted based on how close they are to you. So if they're on the same planet and they're at the same depth, they would likely be able to help you more effectively than others. But that never panned out, and so it's really just more of a very simple digging game where you dig to the core of the Earth. And there is no end game screen quite yet. So again, the analogy that is being provided for the user is a digging mechanic called Clickhole. So at this point, we have all the information here. We've pulled down the repo. We've set up the environment for both Postman and the repo. One thing I do want to call out, though, real fast for Postman is you also need to get the environment variables in here. And so you're going to go into the environment variables, and you're going to click import. And then you're going to just do this little environment variables bit right here. And now you'll see that there is an environment. So we're going to add this environment here. Oop. And we're going to use this one right now. And so this one just has some general environment variables that are used to generalize the requests within Postman. When you see API server host name, that's just localhost, port number is 8000, and then you have the password and the username, password, and email for user testing, and so forth. We're going to just exit out of that, and then let's see, we should be good to go from there. And then we're just going to set the environment to Clickhole right here. So yeah, at this point, everything is configured. You understand that the game is called Clickhole, and it's a game about digging. And before we continue, the idea is that in this game, there's two currencies. One is the depth of the player, which is a progress-based currency, and then there's an actual currency called digging doubloons. And digging doubloons are just something that you accrue as you dig. So as it's configured right now, for every 5 meters of depth, you will acquire 1 digging doubloon. So I realize I've spent a significant amount of time just talking. So let's run this server. If you look real fast at this make file right here, what this make file is a simple set of commands that will help us do general Django commands. But the easiest thing you're going to want to do is you're just going to want to do a clean boot, because there should be no database configured. And all that does is set up the initial Django configurations and the initial workflow for Django so that you have everything that is required. So at this point it is running, and you can see that here. But that's just to do the general deploy. What I would actually suggest doing for higher concurrency is with users is to do the deploy command. If you do make deploy, this actually runs with a gunicorn or gunicorn web server in between that for handling the requests. But for now, we're going to do the make clean boot command and then just go based off of that, because this is just a development example, and then I'll show you further. So at this point, we have it running. Excuse me, I had to get a sip of water. So it is running, and you can see that it's at the localhost port 8000. So we're going to do a simple test and just make sure that this server is running. And we did indeed get a request on the endpoint API v1 ping. So we know that this is working. The typical workflow for this is you're going to want to sign up, you're going to want to log in, and then you're going to want to actually start moving forward with the commands like digging and so forth. So we're going to sign up with the username and password. And this has already been configured in our environment variables here, test0, test password, test0 is the username, and so forth. One thing I want to call out is that when you sign up for this process, you're going to get a token back, and that is actually how authentication is handled through this. It's not a session-based authentication where the server will track that information. Instead, it's a token-based authentication such that this token needs to be preserved for all the requests. And I can go back on that in more depth, but just the understanding I want to communicate is that the user is provisioned a token at every sign up and login. At the next step, you're going to want to log in. And the only reason you're going to want to log in here is because this sign up does nothing just but retrieve the quest. But when you log in, you're going to get a new environment variable that's created called the token. So we're going to click this, and now we'll have the token slurped into our environment right here. And just to clarify how that gets executed, you'll see that there's this test section right here, and this is just some basic stuff to slurp in the data. This isn't a very complicated example. All it's doing is retrieving the token and setting it as a variable. So now when we have any requests, we just say bearer token and then specify that in our authorization header. And that will be provided, and we don't have to worry about authenticating manually from this. So now at this point, you can do some digging for the user. But before we dig, I want to show you what a list of diggers looks like. So let's say you created a digger and you want to see what that digger looks like. You can get the list of diggers from the API/v1 digger endpoint, and we've only created one user right now, and that's with the user ID, and the username is test0. And you can see that there's no doubloons that this user has, and they haven't dug any depth. I believe, and I don't know if I actually specifically handled specific diggers. I think I did. Yeah, okay, so that does work. I'll have to update that appropriately before I send that out again. And but the idea is that this can do a specific digger, and then this can do the many diggers. And so at the next step, now that you know who you are as a digger perspective, and you can log in and authenticate, we're going to use the /dig endpoint of the API to dig. Now the /dig endpoint, when it's hit, is done in the context of the user that is hitting it. So whoever hits it is the one that is making the requests on their account to dig. And the idea with the dig endpoint is that I didn't want to specify any hard-coded numbers or get too complicated with the current implementation, because there is some aspect of like, well, if you are there, it's meant to be like a cookie clicker game in that there are different operations that will dig at a time. And what I mean by that is like you click a button and one could do a digging of like 5 meters, and then another button would be like digging of 10 meters, and then another one would be digging of like 100 meters. And so that kind of variability meant I could code up a bunch of endpoints that pointed to like some same general functionality that just multiplied it, or I could just make a single endpoint and then just say specifying that, you know, as long as the information is there. So this could actually be a digger who does like 1 meter, 10 meter, 100 meter, 10,000 meters, etc. And for the moment, we're just going to do digging 1 meter at a time. And so you just click send, and it says that dig is successful. So you can see that you started at a depth of 0, now you ended at a depth of 1, and you only dug a depth of 1. So we're going to dig 4 more times. We're going to go 1, 2, 3, 4, and now you can see every 5th meter or anything that is divisible by 5 will award a doubloon. And so if we list a specific digger ourselves, you're going to see that we went and dug a depth of 5 meters and that we acquired a meter, one doubloon for our possession. So the key takeaway that you should understand with this is that the only way to accrue in this game would be to discover doubloons by digging. And We can elaborate more on the digging mechanic, but in general, it'll allot doubloons based on any amount. So if you dug 1,000, it'll award the appropriate amount of doubloons, which would be around 200. And if you look at the specific digger information, you'll see that I have 223 doubloons at my discretion. So again, just at a high level, you should understand that the actual gameplay mechanic of this exists in the dig endpoint. At this point, I'd like to take you to look at the items in the shops. So I have hooked up Django to actually create several items automatically. And I haven't gotten too creative with them, but at the high level, you can see that there's an axe pick. It was forged in the mountains of Gibraltar, carried across the coasts of Hakashikaigan, buried in the valley of the ancient Iwak-Savo. And it's just a modest pickaxe that only does one. And then we have pickaxe V2 and V3 down here, where each one does more in terms of that value. So each item has a value, which just means that it is the depth that it allows one to kind of get to in the digging process. And I haven't thought too heavily about how the item should be managed, but one thing I do want to call out is that you can see that there's like an implicit shop price listed with every item. Regrettably, for the sake of expediency, I coupled the shop price and the value of the item directly together. If I had the option, I would have extracted this out to more of like a shop interface and so forth. But at a high level, you should understand that this is coupled with the actual shop itself, and this is actually related to the item. And so you can create items, but it's not something that I would advocate for. This is just to demonstrate that you can create as needed. So you could be like, this is a grenade or like a boring machine, and you could say it's over 9,000 and it's P good. You know, it could be better. It's P good. And then you could just say that this is like a 4-star Yelp, right? And so if you just send this information in, and then you list off the items again, you'll see that it's just adding these information into there. So the thing, you can also delete items. I'm not going to do that. You know, delete operations should be taken more seriously because of making sure that persistence is at least respected in terms of a historical context. But I just wanted to demonstrate that that could be done. And then you can list purchases. Now, with the clickhole game, the idea is that giving and receiving items are done through purchases, and purchases are tracked in the context of a transaction. So it's not necessarily like who gets what, it's more that this person bought this and gave it to this person. So if you say you list purchases, you're going to see that there have been no purchases. And if you look in here, you just specify the user ID, who you're purchasing for, who's receiving it, and the item. So this item ID matches to the items right here. So if I want to give an axe pick, I would use the ID of 1 for the axe, and then based on the actual diggers, I would give it to that. Now I'm going to make a user again. I'm just going to do a quick sign up and slurp another user or two into there. So I'm making a user called test1, and I'm making a user called test2. And now if you list the diggers, you'll see that we have 2 new users and that they are quite significantly behind the other user. At this point, I'm going to call out one more time that you can list the purchases, still no purchases, and now we want to actually execute a purchase. So from a business rule perspective, in this game, you don't want a user to give things to themselves, right? So you want it to let the user know that they can't. So if they specify themselves as the purchaser and the recipient as that, then they are saying, hey, you can't do that, basically. Just a nice little business rule that says, FYI, diggers are prohibited from purchasing items for themselves. But now that I have several doubloons and I want to help out one of the new guys, I'll say, hey, give you this, and we're going to give the boring machine to somebody. And we'll just say, or actually we'll give them a pickaxe. We'll just give them a pickaxe and we'll purchase that item. So you can see that I successfully purchased the item. The item ID is 1, its price was 1, its value was 1, and then this is who actually purchased it, was this purchaser, and that the result of this transaction has left them as a 1 doubloon poorer. And then the recipient is now 1 depth deeper, and there was no errors that occurred. So let's say I did get a little, my friend got jealous and I was like, all right, I'll hook you up, I'll help you out, and I get this guy a boring machine. You can see that now he is at a depth of 9,000, and the recipient was the 3rd player as well. And then, so pretty standard stuff. Basically the idea is just that purchasing can and can't be done. I do want to call out real fast that a lot of this stuff I get for free with Django REST Framework, which is a library that is used in conjunction with Django to support API building. And if you want to see what I mean is, like, let's say I wanted to create a digger. You can't create a digger. There's no mechanism to create a digger with the endpoints that are being used to retrieve diggers. So the idea here is just that there is some mechanism of locking this down, and that is in place. But we're not going to go too much into that. But I did want to communicate that these operations are locked down on a per person, per operation basis. So again, just to call back, we didn't have any purchases, and now we do have purchases, and you can see there two purchases occurred. The first purchase was done by this purchaser, which was the user ID of 1. The recipient was the player 2, and what they got was the axe pick, and then the same for player 2 giving the player 3, and so forth. Now, if you list the diggers here, you're going to see one of the cooler things is just that information gets updated appropriately. So you can see that player 2, while they did go down a little, they didn't go down enough to get a doubloon. But if you look at player 3, they went down enough to get over 1,800 doubloons as a result of the depth being dug. So as a whole, that basically wraps up the API discussion just from a high level so you can understand what functionality is there. I do want to call out real fast that there is a mechanism to see who's giving you what in terms of purchases and what you have given somebody else. And the concept is only codified as a business rule in terms of, there are gifts and then there are presents. And so the idea is just that a gift is given, a present is received. So the idea here is that if you give somebody a gift as a user, you'll see that you have given somebody 2 gifts. But if you want to see the presents you've received, you'll see that the first player who I've been playing as has not received any presents. Forever alone, so sad. And but the idea is that these endpoints are configured as custom endpoints. I would probably, if I had to redo it, it would probably be gift/received, gift/given, and I think that would have been better codifying it with explicit paths, but it's just too far along in the project that I don't really want to go back and make sure it's working. All right, so yeah, once again, this is just the Postman aspect of it, demonstrating it. And you can see all the requests in here just getting logged and so forth. So at this point, we have covered the server, running it, demonstrating the authentication, the digging, the shopping, and the gift mechanic. I'd like to go on a little bit about the testing of this piece right here, because there's some aspects of it that are a little bit nuanced to the Django environment. And we'll just kind of dive into that right now. So I'm going to destroy the database that we've built up. And I'll explain why I'm doing that in a sec. And then I'm going to explain just one really nuanced part of the testing real fast. So I didn't actually do a lot of testing on this. And the reason I didn't is because Django itself is very rigorous for the Django REST framework, and that means if I was doing testing, it would mostly be checking to make sure that it would be more of a functional or integration or kind of a end-to-end sort of thing, making sure that as long as the operation occurred, it occurred correctly rather than unit testing. And that's because the concern with Django is not necessarily did Django do it right, but more that does my product do the user operations correctly? And so it would be like, did my user dig? Did that value return 1? Was that the expected value? And so forth. In the context, though, there was one aspect of this that I did want to call out, and that is the doubloon calculation. The only part of the game that actually does have some really special operations is discovering doubloons, and that is you want to guarantee that every X amount of doubloons you are correctly detecting it. And so in this project, there was only one bit of testing that was really special, and that's here is this calculate doubloon accrual aspect. And so this just guarantees that whatever the values that are passed in, it is appropriately returning the amount that you would expect for the doubloons. How this is done is you just do, and let me make sure that I have the correct information. And so what you'll do is you'll do PyTest, which is the testing framework I have chosen because I actually really enjoy PyTest and I think it's very powerful. And if you do that over here, you'll see that there's over 31 tests. Each one of these is a test and it's parameterized such that it gets fed in as an input-output sort of way, and you can determine it. But basically it guarantees that for each one of these existing items, this is passing correctly. And so this is the unit testing that was done for the digging mechanic. Again, the rest of it was pretty standard Django, so I'm not going to be testing Django because I hope that Django is doing the testing itself. But the last piece I would like to call out is that I do want to show and demonstrate the load testing. That was a requirement of this exercise. So we're going to go all the way back up to the beginning. And for the load testing, what we have to do is we have to make sure the database is super clean. And the reason for that is because the testing hookups that I did to make sure that the load balancing would work did not know of any identity, meaning that they make an assumption that no identities are there and it spins up a bunch of test users and says, okay, I've made all these test users using the sign up endpoint, and then starts hammering the server with it. And it's really, and it works correctly and it does what we need to, but it's just one of those aspects where it's a little bit nuanced in terms of what was required. Okay, so you can see that there's this thing called API load test, and I'll open this up real fast. API load test is executed using something called Locust. Locust is a third-party library that does load testing automatically for you. You just kind of configure it on a per-task basis, and that task will target an endpoint and then go from there. You can configure it with certain credentials. So how it works is this calls the sign up, it stores the token locally, and then if that token doesn't exist, it will try and retrieve it and go from there. And so how this works from the actual interface is that we need to do this from a production mindset. And so the only reason I'm calling this out is that with a production mindset is that Django itself is a development environment, meaning that it's not built to handle web requests. It is built to demonstrate what a web server would look like and how that would be handled, and then template it out, and then you would want to put some type of web request handler in between the two. So at this point, now this would be something that's much more closer to production. It's using something called G-Unicorn. I've heard it pronounced Gunicorn. I don't find that a very attractive pronunciation. And the documentation shows a unicorn, so I'm under the belief it's G-Unicorn. And regardless, all this does is it spins up some workers that will handle the requests, and then under the hood, point it towards the actual Django source code and serve up the pages appropriately. And you can see this demonstrated here real fast. If you just ping the web server while it's running, you can see, oh, okay, that's good, it's working. So then what is required next for this part is to run the load tests. Now, while let me see. Yep. No wonder I don't have virtual environment set up. So I switched into a new terminal, and the problem is in my new terminal I didn't slurp up the virtual environment, which is this bit right here. I also want to make sure real fast that I have Locust installed, because that's not going to help me if it isn't, but we can. It is installed right here. So we're going to go back into that Django source code We're going to go into the test directory, go into the API directory, and then run that load test. Now, at this point, all this is doing is it's spinning up a server, and that's going to be at localhost 8089, I believe, if I remember correctly. And so this is just a dummy interface, and I'm going to just target it to simulate 1,000 users and a hatch rate, which just means how often those users are integrated. Now you're going to see a bunch of failures kick off first, and that is because I don't know Locust at all. This is a new technology that I totally learned for this example. And in doing it, the setup process suffers very much from a lot of noise. And so in the setup process, while it's spinning up all 1,000 users, which it has just completed, it then fails an incredible amount and then goes back to normal as it should. So you're going to see it has an insane amount of failures that it starts off with, and then suddenly after the startup process, they disappear. For the sake of this project, I didn't think that it was something that I was interested in debugging because I didn't think that this project would be used to any extent afterwards. So I didn't find the value proposition of looking into this any deeper to be very attractive. So I only request that you understand that this setup process for the load balancing is done in the context of a little bit of a messy setup, and then afterwards that goes away. So you can see right now this web server is handling over about 100 requests per second, and then that those failures that are occurring are no longer really an issue as they kind of trend downwards. So you can see that these failures right here are very static, and then the actual runtime. So what's going on is there's users who are querying the web page, and I should call that out real fast. If you go to the server of it, you go to v1 or API/v1 here. This is going to show you the actual schema of the code base, and this is just going to be real quick right here, the information. So this is the only public endpoints available, and you would need to be logged in to see any more of these. And because there's no authentication at the moment and no context associated for that, you can't see the available endpoints outside of that from a web service perspective. So, but what that does mean here is that this GET request is getting that same page for the schema, and then the other ones are digging, and then there's someone that are pinging and they're purchasing, and then the sign up was just kind of a one-time thing. And so again, to call out, these failures have been trending down, and they at some point they just kind of go away if you let it run like soak test long enough. Yeah, so that's essentially it. Definitely demonstrates that 1,000 users can be done. I haven't pushed it farther because of a lack of interest, but I'm sure it wouldn't be too much farther from that. So we're going to take a step back, and we're going to end on one little other piece. And we're just going to cancel this out, cancel this out. We're going to go to the front end. So I do want to elaborate. I did have some stretch goals for this project. I wanted to make a front end for this to demonstrate all of this website, and it's really unfortunate because it was an opportunity to use React and then serve up web pages using Django, such that it would be a React bundle, and then that React bundle would use the API that's available to do all the internal working. And it wouldn't have been very hard, but in the sake of time boxing this, I didn't want to get stuck with something that wasn't quite finished. So I'm just going to demonstrate what I did get going, and you'll see that there's a little development server at 3,000, and basically all it is just an example page that is showing what ClickHole could and or would be. You would log in or sign up, and then say like blah blah blah, and then you would submit it, and then you would log in and so forth. Unfortunately, again, the rest of the website did not get finished, so we'll just have to settle for Postman and go from there. This is just a high level. I realize that this didn't drill down into the code or explain much about it from a actual implementation perspective, but that was intentional because I'm looking just to demonstrate that this is a game and what it's capable of. And there are several shortcomings that I want to call out. These are bugs that are outstanding and I probably won't be addressing. One of the things that's interesting is when you're making the requests to the server, you can't do something like ping, and that's just because it's not a very effective. Like there's something that is broken in the actual execution of it, and what I mean by that is there's a property called append new slash in Django that just doesn't seem to be detecting correctly. Django would take this request and force that ping to have that slash, but it doesn't seem to be working. And then just to call out again, this is all the data that was from the users for the load testing. So you can see there's over a gorillion users basically, and each one of them was digging to some degree. So then, yeah. The next thing I want to call out is there's some structure in this code base that I think could have been better. You'll see that Django has a concept of a project, which is something that contains apps. So the API is an app, and then this is a project. What happened though is in the app, the testing got conflated where there's a test directory, and then there's also a tests file. And so I think if I had the opportunity, I would restructure this a little bit better, which is, again, some of the best practices in the file structure. For the API, there is no deduplication of requests for items being made, but I think what I would really do in the long term is do some type of authorization management such that only super users could create it. And then it would be kind of like, okay, have a historical log and go from there to track that information. And then, yeah, the thing that we called out earlier about how an item has its price and a shop value, I would decouple that by putting it in its own place. And then lastly, there is some concern I have about the information that's being propagated in some of these requests, so I'd want to scrub that a little to make sure that it's locked down effectively. I think in terms of that, that is just about everything. So if you have any questions, feel free to ask. Overall, this was a little bit more of a complicated project than I was anticipating, only because it just meant that there were some aspects that needed to be juggled in lieu of others. And I think I got a little distracted from the front-end aspect of making something nice, as well as the authentication aspect of potentially how far I could go into managing those users. But at the end of the day, this does satisfy the requirements that were spec'd out, and I'm looking forward to any thoughts. Loving any discussion. And then if there's any interest in a in the weeds sort of discussion about Django, we can have a separate video for that.